Kinematics 6, motion in one dimension, problem solving will continue. The equations were given already, so we'll continue to do simple exercise problems. Right. Once again, we'll start with the number 1 because I don't remember the number in the previous class. Okay. A body is moving along a straight line. AB with a uniform acceleration. Is a uniform acceleration. At A, it has a speed v1, and at B, v2. Find 1. Velocity at the midpoint of AB. Two. Velocity, average velocity between A and B. 3. Velocity after half the time from A. First, you need to understand the question, and like I told you, you may picture the question either in the mind or on the paper. Going like this, there are 2 points considered in the motion. What it says is at A, it has a velocity u, so not u, v1.
V1.
And at this v2. So exactly the midpoint of AB, that means half distance. After half distance, velocity equals how much is the first question. Sai Ganesh, how do we do this? And remember, the body is having a uniform acceleration.
Yes, sir.
So how shall we start doing it?
Sir, like for the first one.
First one.
You can. Sir, they gave midpoint, no, sir.
So this distance is known, for example, because if it is AB, it will be AB by 2. Or if you think AB is S, make it look easy, AB by 2 will be S by 2.
Yes, sir.
So one equation consisting of V, V1 and S is V square minus U square equals 2S, isn't it? So
Yes,
V
sir.
square here minus V1 square there is equal to 2 into A unknown, S by 2 here. S also is unknown, you can think, that's not a big deal. Now for this also you can write, isn't it? So V2
Yes,
square minus V square. Now this becomes final, this becomes initial. But once again, the same distance and same acceleration. So you can make these two equal, right? V square minus V1 square equals V2 square minus V square. Okay, 2V square equals V1 square plus V2 square. So V equals root over. So that's the velocity at half the distance.
Distance, yes, sir.
Right? So the first answer. Now the second answer, how do I do? Average velocity between A and B. I need not have to do because we already know. If the acceleration is uniform, average velocity is initial plus final by 2. I proved it already previously. Huh?
Yes, sir.
Third, velocity after half the time from A. Don't think after half time it will cover half distance, because it's acceleration. When there's an acceleration, the body covers more distances later. Did you not show something like that? This is the first second, next second,
Yes,
like
sir.
that. The distance goes on increasing if the body is accelerating. In the same time interval, the body covers greater distances in the later times. Okay. So I can't say that velocity after half the time is v, but half the time somewhere wherever it is, don't worry. That velocity after half time, you can say it is v. V equals v1 plus a t by 2. The total time you can think to be, sorry.
Total T. Yes, sir.
So t by, after t by 2 time, v equals u plus at. What do you say? Later,
Yes, sir.
v2 equals, initial velocity will be v now. V1, v2. So final initial. So v plus, once again remaining t by 2. Make them equal. V minus v1 equals v2 minus v. So 2v equals v1 plus v2. V equals, which is same as the average velocity. Is it all right, children? So average velocity is nothing but velocity after half the time. If the acceleration is constant. All right.
Yes, sir.
So can I continue?
1 minute, sir.
You will have to do many problems like this until you feel comfortable to start doing, to attack a new question.
Yes, sir. Done, sir.
Next. Second. Slightly I'll increase the difficulty level. You can say problems.
Okay, sir.
At the moment traffic lights turn green, a car waiting near the junction starts and moves just a minute, numbers. No, I'll just change the question slightly. Turn green. No. This will be an easier sum if I give this, because I put problem there. I'll go for another question there. A car moving with 54 kilometer per hour The driver, I'll write. The driver in a car moving with 54 km per hour applies brakes producing deceleration of the numbers. Just 1 second, because I don't want to spoil the sum. Point 0.3 meters per second square. Let me just the driver in a car moving with 54 km per hour applies brakes, producing a deceleration of 0.3 meters square. Seeing the traffic light turn red. Just 1 second, children. Actually, that's somehow missing. I'll just do the proper question by looking at the actual question. The numbers missed my, because some numbers will not do justice. All right. When the brakes numbers are correct only. Okay. When the brakes are applied, the car was at 400 meters from the signal, traffic signal. Okay. Determine the position of the car one minute after the application of the brakes. Right? See whether you really followed the question. Driver in a car moving with 54 km per hour, or moving with the speed of 54 km per hour, applies brakes, producing a deceleration of 0.3 meters per second square, seeing the traffic lights turning red, whatever. When the brakes are applied, the car was at 400 meters from the signal. Determine the position of the car 1 minute after the application of the brakes. Come on, how do you do that?
Sir, first we have to convert the speed from kilometers per hour to meters per second. Right?
Okay, we do that. 54 into 5 by 18, isn't it? So 15 meters per second. Done. Then what is the second step?
Sir, use S is equal to ut plus half at square formula.
Right. So tell me. S equals U 15 into
15, 60,
and 60.
60
Plus
minus, sir, minus.
okay, I'll write minus. Into 60 square.
3600.
So how much is this?
900 minus, sir, 3 into 360, sir. 3 into 180. 3 into 180.
540, sir.
540. 540. That is 460. No, sir. 360. 360.
That means the answer is he will be 40 meters.
40 meters near. Yes, sir. 40 meters from the signal light.
That's what Amar did. Huh? Let us just see. He already thought that in 60 minutes it only after 60 minutes it stops, he thought. But let me find out the time in which it is actually stopping. Huh? 0. I will use v equals u plus 80. When it stops, velocity is 0. Initially is how much? 15 minus 0.3 into t acceleration. So t equals how much? 15 by 0.3, 50 seconds. So in 50 seconds only it is stopping. So I'll calculate s from there. 15 into 50 minus half, 0.3 into 50 square. So this will be 750 minus 750 minus how much?
750, sir.
375. Oh no?
Yes.
So 375. From here it comes 25 meters from the signal. So this is right or this is right?
Second one.
Second one. So Amar, tell me.
Okay, sir.
Not okay. Do you really understand it now?
Yeah, yes, sir. Yes, sir. Yes, sir.
But anything else people would like to talk about this? Can I continue for the next question?
Yes.
But what is the
Sir, 1 minute.
what is the moral of the story? Why Amar is wrong?
Sir, we should check for how much time the body is actually in motion before making an assumption.
And who will decide that? Acceleration or deceleration?
Yes.
So a simple looking sum, definitely many, if you give it to 100 students, 75 students will do only this, remember. That means they think they've got it right and they'll go wrong. Hello. Agreed?
Yes, sir.
Ganesh.
Yes, sir.
There's no big calculation as such. There is a conceptual, what you call, googly. So you will be tempted to put this first. Whereas you should find out the time in which it is going to stop. And cleverly, he gave only 1 minute. People might argue, sir, after 1 minute, we don't know where the car is. He might have gone somewhere. No. Look, the car should stop. The traffic light should turn green. Only then they will start, right? So it's
Yes,
not
sir.
given a lot of 2 minutes, 3 minutes, 1 hour. He is not given, right? Huh? So it's a quizzical
sir.
sum. It's not even a problem. It is a problem from a quiz. Do you follow?
Yes.
Can I continue, children?
Yes, sir.
Okay. Others, please. Inak and Vishnuvardhan became silent.
Yes, sir.
Some nice questions we can do if people interact. Otherwise, This kind of sums, there's no need to do. Now, a helicopter takes off along the vertical with an acceleration of 3 meters per second square. Okay, and with zero initial velocity. All right. In a certain time t1, certain time t1, the pilot switches off the engine. All right.
Yes.
Now I'll just put in a different color to tell you the separate the situations. At the point of takeoff, you understand the meaning of the point of takeoff? The place of takeoff, huh?
Yes.
Sound dies away, or dies out, whatever, at t2 equals 30 seconds from the beginning, of course. Time is measured from beginning. Is understood actually. Determine the velocity of the helicopter. Determine the velocity of the helicopter at the moment the engines are switched off. If you did not follow the question, you can still tell me. I told you these are better questions now, not substitution questions. Substitution questions are exercise. But when you look at this kind of questions, you need to know how to set up the question first, how to set up the situation and solution there. So first you can tell me what you understood.
Sir, so there's a helicopter which takes off with an upward acceleration of 3 meters per second square.
Okay. This is going up.
Yes, sir.
Its acceleration is how much?
Sir, and after a certain time,
after a certain time, what's happening? The time is
switches off the engine.
The time we don't know. Some T1 he said.
Yes, sir.
Here the engines are killed. So the sound will go away here, isn't it?
Yes.
Then?
Sir, so it
at
says
the
that
point of takeoff means here. There's a person standing there. So what's happening? Actually, he was asking you find the velocity of the helicopter here when the engines were switched off. So tell me, what after this, Vashist?
So that means at T2, was it freely falling or sound dies off?
You tell me. It's a practical situation, no? I've
Sir,
written down the full question as it is given there. Huh? Tell me. Have you understood the question only? That's the basic thing.
yes.
Does the sound even
See,
be in the equation?
speed of sound also may be given. For example, if you want, speed of sound may be 320 meters per second. Tell me, what is the question asking you?
Sure.
At the
The
point of
velocity.
takeoff, sound dies away after T2 equals 30 seconds from the beginning. When will the sound, why is the sound dying off? Tell me. Because engines are off.
Turned off.
So, but remember, the moment engines are off, the sound doesn't die away here, right? Because sound takes some time to come to you.
Yes, sir.
Isn't it? That's the trick of the question. All right, let me see how much distance the helicopter would have covered here. Until there, U is 0, A is given. Don't worry about G, because this A is taking care of G, everything. Huh?
Yes, sir.
So what should I do? See, there'll be G, there'll be upward force, all the resultant acceleration is 3. Don't worry about G here. Do you follow my point? Huh?
Yes, sir.
The net acceleration is already there. So if U is 0, how much distance it would travel? Half A T1 square.
Yes, T1.
So the helicopter went up to half a T1 square. At that moment, the engine is switched off. So sound already was emitted, no? Huh? Hello.
Yes, sir.
So it
Yes,
takes
sir.
some time to come back to this fellow. Huh? But after
Yes,
some
sir.
time, the sound was not heard. Hello. So
Yes,
this, and he says it dies off after 30 seconds for him. That means it will go T1 and takes some time to come back. That time is 30 seconds. So I should
Yes.
write T2 equals T1, that's the time to go up, plus for the sound to come back to you, that is half A T1 square
square.
by
320, sir.
speed of sound. Tell me whether you understood this particular equation or not. Suhita, Amar. Tell me. Instead of mincing more words, I've just shown that in mathematical form. So maths will give the same meaning to everybody. That's why we need to go for maths. Your English words may be different for different people, but maths is a common language. So does it convey some meaning to you?
Yes, sir.
And can you connect it with the question there? At the point of takeoff, sound dies away at 30 seconds. That means we don't know T1 is less than 30, right? So T1 times it goes, 30 minus T1 times it comes back, after which the sound is gone. Isn't it so?
Yes,
Yes,
sir.
sir.
So T2 is there. Everything is there. So I should get T1 first. So 30 equals T1 I don't know. Plus half into A is 3
3.
into T1 square by 320. So a quadratic equation in T1 you get. Tell me how much is T1 fast. Once T1 is there, the velocity here will be what? V equals 0 plus 80. A is 3 into this T1 you substitute. You get your final answer. That is the question. Come on. Hope people understood.
Yes, sir.
So, Vasist and others, tell me. And I warned you, these quadratic equations keep coming. That's the reason why we did quadratic equation in the beginning only, right? Either by factors or by quadratic formula, which you should have done in your 10th class. What is that? When ax square plus bx plus c equals 0, x can be written as what? Minus b plus or minus root b
3 square
square
minus
minus
4ac by
4ac
2a.
by 2a. This is a quadratic formula. This is how you find out x in general if you cannot factorize it.
Yes, sir.
So you want me to solve for you this one? I want at least one or two of you to finish it and tell me.
Sir, the numbers are actually quite big, sir. So
Nah, why should you worry if the numbers are big? The questions will be like that. You know, 3, 10. Okay. So what will I get? This is 640. So 10 equals T1 plus T1 square by 640.
Sir, like you can't cancel it directly now, so there is an addition in
yes, sir. There's a plus there.
Yes, sir.
So isn't it? I was just waiting whether somebody will object or okay. Come on, do that. So 10, so not 10, this is how much?
30.
30. T1 plus half A 3 T1 square by 320. Nothing cancels out, right?
Yes, sir. You have to multiply it.
Sir, so 3t square plus 640t minus 9600, sir.
Now, will something go? Even now, nothing goes, right?
Yes, sir.
Yes, sir.
Right. So, substitute the formula and do it. That's what is given. We can't help it. Hello. Others are not
Yes, sir.
responding only. This is A, this is B, this is C. At least one of you give me, I know the answer. You give me the answer, I'll write it. Otherwise, I should change my screen. Substitute what is there. Don't expand it. Keep as it is. Things will become easy. So people are not helping. A, B, C we know. So T1 equals, what should I get? Minus B. What is minus B? Minus 640, right?
Yes, sir.
Plus or minus B square, 640 into 640 minus, once again a minus is there. So plus 4AC. 4 into 3 into 640 into 30 by 2A. 2 into 3, 6. So 640 is here, 640 is there. Huh? So it's going to be a little easier. You are refusing to finish it.
Sir, I got one solution is 80/3 and other as -2.
That
Minus.
that can be ignored. So 80/3
Yes, sir.
is correct. Huh? So
Yes, sir.
the answer will be this one. 3 into 80/3. I think so. 80/3, is it right? Most likely. 80/3 are
Sir, 80/3 is less than 30. Sir.
yeah, that's correct. So that's what the problem is about. Can I go to the next question?
Yes, sir.
1 second, sir.
Yeah.
Yes, sir. Done, sir.
I think it is 80/3. Other minus sign, minus time is ignored.
-200.
So can I go to the next question, children?
Yes,
Yeah.
sir.
Yes.
Right. Fourth. Another decent question I'll give you. A body starts moving with a constant acceleration A along a straight line. Okay. At a time T1, after the beginning of the motion, at a time T1 after the beginning of motion, the acceleration changes sign. Okay. Remaining same in the magnitude. Image stands for magnitude. Find the time T. From the beginning of the motion. From the beginning, in which the body returns to the starting point. Hope this also you understood the question. So instead of me directly starting and doing, let us just discuss it for a while, deliberate it for a while, over it for a while. Ganesh, what should I do with the question?
Yes, sir. Like,
It starts moving, he said, so maybe initial velocity is 0 only, okay?
yes, sir.
So it in a straight line, it is going to move.
Yes,
With
sir.
u equals 0, but there is an acceleration for it. So what is happening?
Sir, like in the question they gave in the beginning, it have a constant acceleration.
From the beginning,
Yes, sir.
A is the acceleration I told you. For time t1, it travels with this acceleration only. But at this point, something is happening. What is it?
It starts to decelerate, sir. So the body slows down.
It doesn't stop here. Huh?
Yes,
The
Yes.
sir.
body slows down. Somewhere, the body's velocity becomes 0 again. But the acceleration is still there in the backward direction. So
Yes, sir.
the deceleration now becomes acceleration. Right? So it goes back like this. That's the question. Hope you understood it. So that is the one we need to set up every time. That is not connected with physics. Oh, sorry, that's not connected with mathematics. It is connected with physics. What is happening there? That should be actually shown in a picture form there. Or for you, you should need to think in your mind if you want to do things fast without writing too many steps. So, did everybody understand this?
Yes, sir.
You know,
Yes, sir.
this acceleration here became reverse. So the body was decelerating, stops. But even then, this acceleration is there, children. So it will accelerate, velocity keeps increasing, it will go to the starting point and maybe continuing after that. But he's saying from here to here, starting from here, I think. From here to here, what is the time he's asking? And naturally, the time will come in terms of this T1 apparently. So tell me, how should I do? There are 2 or 3 ways of doing the same thing.
Yes, sir. So what we can do is we can find the velocity at after t1.
At this point, that is v equals u plus at.
Yes, sir.
Isn't it? So that will be a t1 velocity at this point. Then after that, what should I do?
Sir, so after t1, the current velocity is a t1 and the final velocity will be 0.
0. Deceleration is a.
Yes, sir.
So you want me to find the time?
Yes, sir. So using the same
0 equals u at1 minus, tell me, v equals u plus at. U is at1 for this motion from here to here, right? You want me
Yes.
to take this time to be some t2?
Yes, sir.
So u plus a is a same a1, isn't it? Into t2. Hello?
Yes, sir.
Yes. Yeah.
Yes, sir.
at1 initial velocity, final velocity is 0. So 0 equals initial minus a t2 until here, u plus at, right? So I'm getting t1 equals
Yes, sir.
T2.
T1 is equal to
T2. Yes, sir.
Yes, sir.
Yes, sir.
So now I've got t1 plus t1, 2t1 until I have, until here. Very reasonably so, children. You could have guessed it also. Starts from rest. In t1, it gets some velocity. If the same acceleration is there, but in the opposite direction, shouldn't you take t1 more time to stop?
Yes, sir.
Do
Yes,
you
sir.
follow my point?
Yes, sir.
I made you prove it, actually speaking. Hello, children. If
Yes,
you
sir.
throw a body up, it takes 2 seconds to go to the topmost point. While coming back also, it will take the same time because the same acceleration is there. While going, it is deceleration. While coming, it is acceleration. Here,
Acceleration. Yes, sir.
from here to here, acceleration. From here to there, deceleration. So this distance and times will be same. Okay. Hello.
Yes,
Yes,
sir.
sir.
So from here to here it took t2 one time, but now from here to there, how much time it takes we want. Started from zero velocity, right? Huh? So how much time it takes from here to here? How will I calculate?
So using s is equal to ut plus half at square, we can do that.
But we know that we should know the distance before that, isn't it?
Yes, sir.
This from here to here, I should know the distance, Vasist, right?
Yes, sir. For that, we can use s is equal to.
Now this distance will be what? Half a t1 square
T1
until,
square.
until
Yes, sir.
here. I need not have to do anything. Even this should be half a t1 square, whichever way you calculate.
Yes, sir.
So the total distance it goes back is how much?
81 squares.
81 square. Now the distance is there. Initial velocity is there. So I can write S equals 0 into some T3 you say. Huh? Hello.
Yes, sir.
Yes, sir.
AT1 square equals distance equals U 0 into T3 plus
T3 plus
half A.
AT1. A3. Yes.
t3 squared. Yes.
Hello, this distance is.
Yes, sir. Yes, sir.
So what do I get now for T3? This AA goes to T1 square for T3 square. So T3 equals what?
Root 2t, sir.
So therefore the total time is 2t1 plus 2t1, that is t1 into 2 plus.
Root 2.
Hope people understood it.
Yes, sir.
So it was actually within your limits to have been tried. Huh?
Yes, sir.
Only thing is we need to believe in ourselves and coolly should do these sums. You cannot get them directly unless you set it up and solve it. Is there any other way of doing it? This is very reasonable. The way we did was clear. Every step, every stage we understood. But you can be a little more mathematical also. Finish it off. I'll go for that after this. Actually, this next distance I did not even calculate. You have any problem with this, children? I said half 81 square. I took directly half 81 square. Is it okay? If you want to see how, I'll tell you. This S equals, S1 equals Vt minus half 80 square I can apply. Children. V is 0. A is minus. So minus goes. A T square. T square is how much? T1 we calculated. So half 81 square straight up. Hello, whether you followed it. Children, come on. So half 81 square, now half 81 square later. So when it comes back, it will come back 81 square in a time of root 2 T1. So the total time to come back is 2 plus root 2 into T1. So Hita, do you follow?
Yes, sir.
Suhita. And Vishnuvardhan, Enoch,
Yes, sir.
Yes, sir.
Sai Ganesh, Amar.
Yes, sir.
Yes, sir.
Amar, have you followed? Damodar,
sir.
I don't know. Damodar and what is Zuhair? Zuhair. You need to speak. These are all very interesting, nice sums. Can I continue? The
Yes, sir.
same problem can be done slightly different way, I told you. Shall we try that?
Yes, sir. Yeah.
So I'll just go for the next page. I'll go for the next page, but remind me of the situation once again. Look, starts here. Huh? travels for t1 time with acceleration a, then from here the acceleration is reversed, so probably it will travel same distance, maybe, we don't know, we can just write whatever you want. So velocity becomes 0 again, then since the acceleration is still there, it goes back here. Children, if it goes back here, isn't the displacement 0?
Yes, sir.
So can I use that idea?
Yes, sir.
Until here, it already covered the distance of half a t1 square
T1 square.
and had a velocity of a t1 here. Do you remember?
Yes, sir.
So I measure my time from here now. From here to here. Do you follow the way I put it? Hello?
Not really, sir. But could you just
Look, time to go there and to come back is some t2, I'll think.
Yes.
okay, sir?
My origin of measuring the distance is here because I want to make something 0. But my measuring time is from here. Because I already know the time t1 here. I don't care. The time is already there with me.
Yes.
I've come here. I've got a velocity of a t1 here. From here to here, I'll take the time to be t2. But I want to use s equals e2 plus half at square and make s 0. What will I do? Look, 0 equals half a t1 square plus a t1 t2. It's minus sign, though it changes this thing. In the beginning, it is minus. So this is S0 if I want. This is ut minus half a t square. This I'm writing. Hello? A
Yes, sir.
t minus half a t2 square. This is one distance from here to here. So if you solve for t2 here, you'll get in terms of t1, right, into something. Then this t2 plus that old t1 will give you the answer. My position coordinate, measuring my position is from here, my time is here. That's why I wrote initial displacement also here, half a t1 square, because this is my origin of measuring distance, right? Hello?
Yes, sir.
No response. Deliberately I've done this because of that. How to change your origins and shift the origins is very important. My x equals 0 is here only, but my measuring my time from here. Try to understand. So shouldn't I add this one, half a t1 square in the beginning?
Yes, sir. Yeah.
So solve for t2 from here and tell me what are you getting. Hello? S0 plus ut minus half a t2 square. Why I wrote minus here is in the beginning when we started, a is negative only, right? You need not bother whether it is stopping and coming. Though I'm showing it is going and coming back, that you need not know. You understand my point? You need not know that it's coming back. Just put a t1 t2 minus half a t2 square and this equals 0. You'll automatically get the time from here. That's the power of maths. Hello?
Yes, sir.
So I need to solve for what from here? T2, right?
Yes.
So A goes, A is there everywhere. Isn't it? Half goes, but 2 comes here. So I'll get T1 square plus 2 T1 T2 minus T2 square equals 0. Hello?
Yes, sir. Yes, sir.
And T2 is our variable, children, not T1. T1 is already there. So you would like to write in the regular formula, you can do that. T2 square minus 2 T1 T2 minus T1 square equals 0. If you want to convert, I have no problem. So T2 equals minus B. minus of minus 2t1, 2t1 plus or minus b square, 4t1 square minus 4ac plus 4ac by 2a. I'm not too sure whether people followed it.
I think it's 41, na, sir.
Sorry,
41 square.
4t1 square plus 4. This
T1.
is 4ac, right?
Yes, sir. C is minus T1 square.
4t1 square, isn't it? C
Yes.
is t1 square.
41.
T1 square.
So what do I get now? So this 2, this 2, this is
4.
even this 4 comes out 2, no?
Yes. Both forces cancel.
So what will I get? T1 plus or minus root 2 T1. Am I correct?
Yes, sir.
Minus will be ignored because it will be less than that. So it is T1 plus root 2 T1. Add it to this T1. This is for T2. Right. So T1
Yes.
plus root 2 T1 plus T1 is the answer. That is 2 T1 plus
Root 2
2
T1.
T1. Just check back in the old answer. But see how the logical approach has helped.
Yes.
So actually speaking, you need to discuss, analyze, talk. That's why a teacher is required. Otherwise, you don't require. Like nowadays, people keep listening to various videos, no video lessons. I was watching. He was defining momentum. Momentum, linear momentum equals P. P equals mv, mass into velocity. What is linear momentum? It is mass into velocity. Once again, you'll say mass into velocity. So after saying that too many times, people, I understood. What is that they understood? Nothing, practically nothing. Probably people don't read, therefore they think after listening too many times, the words stick. You can manage something out of it in other subjects, but in physics, no chance. Believe me. Physics, one way is easy, one way is difficult. If you understand the way to do, correct way to do physics, which looks in the beginning difficult nowadays, because until 10th, some of people stopped doing that kind of a thing. But once you get into the mood for it, that's the most easiest subject. And I want not only few people like this, but others to keep speaking, keep talking. Then you'll improve. Otherwise, no. Okay. Thank you. I'll stop it now, and I expect you to continue to do the vectors problems from today itself.
Okay,
all right,
sir.
Vishnuvardhan. You need to have some separate notebook for assignments and not ticking like that. Actually, what solution you did, you just write 1 or 2 lines. 1, your solution, your key. 2, 1 or 2 lines, solution, key. 3, solution, answer, then key. Like that, you should go on doing until 123 questions. That's what I expect better students to do every time. Okay.
Sir,
Yes.
can you explain the first step? I didn't quite understood it. And it's the simplification, but 0 is equal to half 81 square plus.
First, to make full statements, actually, I won't be understanding.
Yes, sir, I didn't quite. How did you simplify this? 0 is equal to half 81 square plus 81 into T2 minus.
After the whole thing, if you ask this, how did you do means what? What I've already done it. Tell me what is troubling you there.
Like I didn't quite understand. How did you get it, sir? By ut plus r2 of it is square.
Okay, Vasis, tell me, did you follow it? Because I'll do this. I will discuss the same thing again. No, just now you're proving. That means somebody talks it too many times, it will stick. Just now I was joking, no? So you're saying that's only correct. I've already done something. So you need to stop from there, no? You need to start talking from there. Vasis, tell me, what did you understand here?
Sir, should I?
He says, why did you make, what is this equation? He's not following.
Yes, sir. Sir, like we took from A, like we took AT as our
I used the
initial
words. I took my origin for measuring displacement here, but time I started here, I told.
Yes, sir. Yes, sir.
And I did not even know that it's coming back like this, believe me. For our understanding, I showed it. You do not even think that it's coming back. Do you follow my point?
Yes, sir.
A is reversing. So if I take in time t2 from here, it stops. Sorry, in a time t2 from here, it goes back to this point. Hello.
Yes, sir.
So
Yes.
I should write u t2 minus half t2 square plus
Plus
this is
T1.
equal to
Yes,
0,
sir. Yes, sir.
isn't it? So
Yes, sir.
I did not even
Yes.
know it's going, stopping, coming back, because that's the reason I took ut minus half at square, because in the beginning I know it is only opposite to the velocity. Velocity is in this direction. Velocity
Yes,
is this way, acceleration is this way. So from here, it takes t2 time to go here. Do you follow my point?
Yes, sir.
Yes.
Hello.
Yes, sir.
So when it goes here, was a displacement this one, but since I took my time here and my origin of coordinates here, I should add this, isn't it?
Yes, sir.
In
Yes.
our formula, S equals ut plus half AD square we do, because we took initial displacement 0. SE minus S0 you should write, isn't it? If this is satisfying you, I can write that. SE equals S0 plus ut plus half AT square. So S0 is already there. SE is 0. Tell me now. Vishnuvardhan.
Yes, sir. Understood.
When we derived integral ds, it should be not 0 to s. To make it more general, s not to s. That means I need not have to start from here. I can start from somewhere, but I can take my origin of coordinates here, x equals 0 here. In that case, I'll get s equals s0 plus ut plus half at at square. Tell me.
Yes.
Vishnu.
Yes, sir.
So can I close now?
Sure, sir.
Yes, sir.
Yes, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.